Class, I want you to know that the truth is a lot of DEs cannot be solved. That's the truth. Even with all the math that we have today, right? Many of the DEs cannot be solved for exact solution. No? It means cannot be solved analytically. So for the reason, math people are very clever. No? If you can't go this way, they will think of another way. And one other way is the use of what is called slope field. Okay, I'm going to ask you this question, Look at this question, word 11, word example 11, right? Let's see if anyone here is able to stand up and tell me what is this equation, how is this equation, how is this table, and how is this diagram related. Give a sound that maybe 30 seconds while I want to check. Where are you? Still sick again. So Zoe is back. There's one more person. Oh, Theophilus. Where is he? Will they be back tomorrow? Okay, we gotta look into the sky, look at where the star is, so we know whether they're coming tomorrow, is it? They didn't say it, huh? They didn't say. Okay. Alright, it's okay. So can someone tell me the relationship between these three things that you see? Very good answer. They're the same thing. Okay, can I say something about it? 键盆. Actually, it's not a good idea for 键盆 so far away from me, I prefer 键盆 sit right here. Yeah. 键盆, and before I make a way to the seat, can you tell us? What do you think? What do you think is the relationship between these three things? Huh? Okay, you can go back to the seat there. Here. Okay. So what this table is trying to do here, this table is trying to construct a table of gradients. If I ask you, why is this number here 0? It's because according to this dE, dy dx is equals to y minus x. So you take the y value minus the x value. So you get 0. And the next number is 1 because you take the value of minus 2 minus the x value of minus 3. You know what I mean? And so on and so forth. So by plotting the corresponding x and y values into the dE, you actually obtain this table of gradients. And what happens is, you transfer this table of gradients into actual drawings. So like at the point minus 3, minus 2, minus 3 and minus 2, right, it has a gradient of 1. So you mark a small dash with a gradient of 1. And the boy beside Kurdish is definitely not in my class, right? Are you in my class? The side, on the left. The one on the left. Sure, he can. But I'm just afraid that Kurdish is distracted. I see Kurdish eyes going leftward. Feel free to stay behind. Really, you did? Okay. So Kurdish, tell us what is happening in this diagram here on the right.
The slope of the line corresponds to the number.
Great. So you are transferring all the values of the gradient into pictures. When I ask students to draw slope field, everybody say, what's so great about it or so difficult about it? No. The truth is, many people don't get full credits when drawing a slope field. The reason is because they're not careful, no? Like a gradient of 1, if I ask to draw a gradient of 1, how I check is, I will actually look at nearby points to make sure that, say from nearby point, right? I will make sure that you really get a gradient of 1, I will check. like say if we're given four dots, right? If at this dot here, you want to draw a gradient of 1, I want to make sure that the line is actually this direction, you know. I will take a ruler to put over it and make sure that it is really inclined in that direction, you know. If anything falls short of it, therefore you're not drawing it carefully. You know what I mean? So to get full credits for the slope field, you have to be very mindful that you must draw it carefully. For gradient of 1 is not too bad. But for things like gradient of 2 and so on, right, it may be harder, but it is achievable. Let me illustrate to you what I meant, you know. What I meant is this: if you say you're given a page that's like this, and then they draw for you dots, okay, right? And then if you're asked to draw a slope field with a gradient of 2, you want to be very careful, note that you want to actually make sure your marking is like that. Something like that. So that this is in line. If you're asked to draw a gradient of 3, I would expect you to be very careful and take reference from nearby points and truly draw a line with gradient 3. To distinguish between gradient 1 and 2, it's not too bad, you know. But to do it between 2 and 3 is harder. And between gradient of 3 and 4 is harder still, you know. And then later on you reach gradient of 6, wow. You know what I mean? So therefore, if you're not careful, if you just use freehand to draw, believe me, you know, 1 is not too bad, 2 is not too bad, then come to 3 and 4, it gets harder and harder. So therefore, you want to be very mindful that in drawing the slope field, you really want to take reference from the nearby points. And in this diagram, right, it is done very nicely for you, not by hand actually. There are a lot of software that can generate for you slope fields. In case you don't know, GeoGebra is one of them, right? If you are more diligent, you can draw a so-called denser slope field. How do you get a denser slope field? Maybe you plot more. Instead of just jumping from 1 to 2 to 3 to 4, you know, you maybe have an x is 1.1 and a y is 1.1. When x is 1.2, y is 1.1. So this, if you were to plot in final quantum, right, then you get a so-called more dense or denser slope field. Okay. Now in this diagram on the one below, it shows you that you have a slope field, and in this diagram it shows you a particular solution that passes through the point 0, 2/3. And the truth is, the drawing of this arc, is totally, okay, let me use this word now, aggregation. If you don't understand this local term, it means guesstimate, okay? Now, you cannot say my guesstimate for this one, after all, is guesstimate to pass through a point here. I draw a slope field that is like that. I mean, that is totally wrong, like that. You cannot say my judgment is so poor. Truly, your judgment is poor, I know. And for a poor judgment, therefore you don't get a credit. You cannot say math is about all calculation and this kind of a freehand drawing. They cannot penalize me for having a wrong judgment in drawing. Cannot, you know. To go along with the math training, right, you are expected to be able to exercise judgment to draw geometrical objects. Like for example, if I ask you to draw a square, if you draw a square that's almost like a square, okay, I know. But if you draw a square that's obviously not a square, like for example, if you draw a square, ask you to draw a square, you draw like that now. Okay, that is totally wrong, Likewise, if you are asked to draw a slope field, the truth is you must exercise judgment, your gut feel. Based on your gut feel, you think that the ground should be curving like this. Right? Believe me, if all of you exercise good judgment, good mathematical gut feel, believe me, if I ask you to draw the particular solution curve, right, for a solution that passes through this point, I would say in this class of 21 students in 504, including those absentees, I am very sure all of you will draw something like this. If you draw something that's totally different from this, right, then there's something not right, really not right. It can't be, we can't be that wrong. Our school admission system can't be that wrong in the middle. It's true. Jianpeng, why do you respond with a hearty laughter? No? Okay. Now to test my hypothesis, can all of you try to draw the solution curve that passes through 0, 1? It's not drawn there. That one that C is 0, 2, third. In case you can't see, it's 0, 2, third. Okay, now to draw 0, 1. Okay, you don't look at what your friend is drawing, you just draw. So as I said, you got to exercise good gut feel, mathematical gut feel. Let's see who are the outliers who draw something that I don't expect, you know. But here you're sitting so far away now. What drove you all to change seats? Your mentor suggested like every term you want to change seats. Okay. At least if you have to suffer, it's only one term lah. If you sit in a position that's not so conducive. Yeah, this is one of the best prime location. Okay, let's test my hypothesis that our NUS High admission system is correct. Can all of you lift up the book and show me your slope field that passes through the point 0, 1? Just lift it up, you know. Let me see. Okay. 接盆呢？是直线吗 ？OK。斜了斜。哪里？啊。这里看错了，看错了。Okay. Zoe, where's your line? Where's your line? The way I asked, I know it. Arohi, too much of chemistry. Hey, off the window. What is happening? In your language, is that a word called Tamil? Brother. Oh, brilliant. Okay. Yeah, I'm right. Our school admission system is right. Yeah, I'm very pleased. Okay. For the next question, now do. Can you draw the slope field? So now you want to draw your slope field. Okay. Are you ready to make a comparison? If you're ready, I'm going to review what I have on my copy. Are you ready? All drawn already, all drawn. So be very careful about drawing slope field. It's not anyhow one. It is drawn with a lot of care. For the matter, in math, right? In math, sometimes we do trial and error, but the kind of trial and error that we have in math is not trial and error blindly one. It's not, It's to trial and error intelligently. It's not blindly one. Let me know. So likewise, in drawing a slope field, although it's something quite trivial, if you don't do it well, you get 0. So to get a slope field that's like this, right? You want to make sure that you draw them that nicely. Kai Wen, you finished drawing? The same. Okay, number 13. In number 13, right? You are provided the slope field, and now you want to try to draw the solution curves for these 5 examples: A, B, C, D, and E. This is a case where you have to exercise good gut feel. And this time, I would expect all of you to already learn from the earlier example, and therefore, you will exercise good judgment and draw it carefully. Like in the case of this, it means when x is 0, y is 0. So that means to say it must pass through this point. If you're asked to draw a slope field, a solution curve, you're asked to draw from the slope field a solution curve that passes through the origin. How do you think it will look like? Yep, it's a horizontal line. And now with more confidence, you want to now draw the particular solution for the B, C, D, and E, and then you will see something nice. After drawing this, right, I would like you to tell me what you see. Okay. Of course, some of them are not lines. In fact, most of them are curves. Okay, have you all finished drawing the 5 particular solutions? Okay, Chen Yan, you're looking at Kurtish's screen, right? Can you tell me, after he has drawn all the 5 solution curves, what do you see? Can you describe the thing that you see on his screen?
I see 5 solution curves.
Can it be something more interesting? Some more interesting description of what you see?
Like there's 3 curves and 2 straight lines. These 2 straight lines are at y0 equals 0 and y0 equals pi.
Then let's hear from Jingwen. What do you see? What do you see, Jingwen? Okay, let me tell you what I see, okay? I see a set of lips. Lips.
It took you guys right now to realize that.
You look like lips,
I
isn't it?
really saw that and I hated this.
You did?
I didn't want to say anything.
Lips. They look like lips. Don't you think so? You look like lips.
You know what it looks like? It looks like a slingshot. As it progresses.
So you want to draw lips on a computer graphene, you just produce the 5 solution curves that pass through these 5 points. You get a set of lips. You just ignore the rest of them. I think you do need the straight line, because when your lip close up, right, there's this straight line. Okay? I find it very amusing, no? Okay. Alright. I'm sure you do. Okay, there's another one. 14. Okay, so wait, before I go on, 13, anybody has an issue? So you have to exercise that gut feel, that you are able to actually exercise the good judgment, math judgment. For the matter, as a math and a science person, right, you should be able to tell me roughly how heavy is 1 kg, or you should roughly tell me how long is a meter. When my daughter is young, I always ask her, roughly how much is 1 centimeter, and she should show it to me, It'd be very shocking if your age group say 1 centimeter is about like that. Then the whole school system has failed, It can't be, it can't be. Okay. To test things out. To test things out, okay? What is the distance from Singapore to KL? Cannot check internet. Cannot check, let me guess. Wait, is that totally recorded? Okay, where did he go? It shows how mature our 17 and 18-year-olds are. 16. Oh, 16, okay. Still young, still young. Can savage with
16 or
Okay, from Singapore to Malaysia is about 330 kilometers. Huh? Okay. 353. Thank you for the correction. So maybe plus a bit more here and there, I think. Yeah. But I remember driving up to KL. I've driven up to KL myself before, no? Yeah. I've also driven up to Genting.
What the hell? How do you pronounce that?
Genting Highland. Okay. Stop it. Try the next one. Genting. In Malaysia it's called Genting. In Singapore we call Genting. Likewise, IKEA, right? We call IKEA, right? Yeah. In Sweden they call IKEA. Yeah. I first heard the word IKEA when I was working in Sweden. Then suddenly the Swedish guy would come and say IKEA. I could not ring a bell, no. At first IKEA. What's IKEA, no? So it took me a big adjustment. Okay, try the next question.
She wanted to check kill.
I seriously don't want to live in Sweden for too long. It was very, very cold. And remember, yeah, very, very cold, very, very cold. And in Sweden, you see light, daylight, like maybe 3 months in a year, you know. About that. Full daylight, yeah, fully daylight, about 3 months in a year. Up north of Sweden, right, you see sometime in winter, right, see daylight for 2 hours a day. Yeah, it's that bad. I remember was in Sweden, there are people who told me, some people could not bear the gloominess, the darkness throughout the year. Actually, it triggers suicide, you know. I'm not sure how true it is, yeah. Okay, for question 14, right? For question 14, okay, let's see again, okay, let's see, I'm going to ask you, to raise your hand if you have the same, okay. Most people make mistake in this bottom part. Most people make mistake in the bottom part, you know why? They actually pass through. All the way down. All the way down. Most people. Let's see a show of hand who went through the x-axis. Just show of hands for this question. The solution curve that you drew. Did you have a solution curve that actually tapers toward the x-axis, or do you have a solution curve that passes through? I told you again, our admission system is correct. Yeah, quite robust, you know. We went through very rigorous thinking, you know. In the middle. We believe you are sporting talents. You might not show up as a very high PSLE scholar, it's okay, you know, but we believe we are getting talents. This guy, Chap, you look sus, you look very sus. This part here, right? Chap is very happy, I guess, very happy. Okay, over here is quite a bit to read. These are pointers. These are so-called pointers that aim to help you to do the mix and matching question. Ups. Okay. Pause. Is it your notes? Is it your notes? Let me see. Okay, wait. 等一下。Okay, 等一下。Okay. Okay, this one. So in this question here, you are given 4 slope fields, and then you're trying to do a match. Which DE goes with which slope field? And earlier on, you read a list of pointers, and this list of pointers aim to help you to identify which is which. How do we do it? You know, you look at the first DE. Okay, look at the first DE, and Zoe, which one matches the first DE? At the count of 5, let's say. There's no yes, no. There's only 1, 2, 3, 4. Zoe is obviously very happy sitting next to Arohi, you know, I think, no. Because it seems like these two are good friends. Okay, Arohi wants to say that. I think she says not a good friend of you. Okay, part A, DE. Which diagram matches the part A, DE? Zoe, please. How do we tell? Based on the equation, you can tell that when y is 1, right? The y prime is 0, right now. So looking at the diagram, you want to look, in which of the slope field would you have gradient equal to 0 when y is 1? And you look at first, second, third, and on the fourth one, if I have to amplify it a little bit, can you see on the fourth one, right? On the fourth one, this is actually 1, you know. It shows you that on the fourth one, when the y coordinates is 1, the slope field registers 0 gradient throughout y equals 1. This is the only graph among the 4 of them that has this feature, and therefore I am very sure that the fourth graph matches DE part A. That this one, right, matches the DE of part A. Oh, sorry, I mean part 5, part 4. Suddenly, I don't see Min anymore. Where's Min? Min, is Min's class?
Mean is definitely not.
Okay, I mixed up. Because Min always is there, is he? Yeah, in that class. Okay, so that's how I identify that the part A, DE matches diagram number 4. So now we got 3 to match with 3. 3 with 3, right? Altogether there are 6 possibilities, okay? Let's see if you can get the right one. Okay, now for graph DE, B, C, and D. Okay, I think it's easier to deal with C first. Yeah, it's easier to C first. I see it's easier. I'll tell why later though. If you look at the part C, D, E, right? It tells you that along the line y equals to x. Along the line y equals to x, and along the line y equals to minus x. The gradient is 0. Okay, along the line y equals to x, and along the line y equals to minus x, the gradient is 0. So for part C, right, you want to look at the 4 or the remaining 3 graphs and see which one has this feature. And let's hear from Kenneth, because he said, oh, means he has spotted it.
What?
You haven't? So the O is for sure.
No, for this question, I just plug in numbers and see which one might be.
Oh.
Because there's x and y, right? So if I look at that, like say random number like 2, 3, I put on the top y5, then
Sure.
C,
Yeah.
3.
You can plug some values.
Yeah, I'm supposed to get like 5 and check out it's about 5. Then, yeah.
Sure. Right. Alternatively, you can notice that actually the gradient will be 0 along the line y equals to x, and along the line y equals to minus x. So based on this, Jianpen, which one? Number 3 is right! Okay, so sitting in front helps, Jianpen. Sitting in front helps. Yeah, it does. And now we have 2 more to go. Okay. Kane, which one to pick, the B or D first? Anyone, is it? Okay, B. Why is B number 2 and not number 1, you know? How do you tell? Okay, if you don't have a previous page, how would you have identified that 1 is for part D and 2 is for part B? Same, you know, for B also same thing. B and D have the same feature that you told me about. He said the gradient is 0 along the line y over x, right? B, the differential equation in part B and differential equation in part donkey the same, you know. Along the line y equals x, the gradients are both 0 also. Not bad, not bad. But let's hear from Kate. Say. Right, right. One of them will be steeper, right? Yeah. Yeah. For this one, right, gradient for these two, right? When x is 0, the gradient will be bigger, likely to be bigger for this one than for this one. Say for example, at a point 0.05, right? Part D will have a steeper gradient than part B at the 0.05. That's why, based on this kind of a judgment, Kenneth and Kane and Jianpeng, right? They spotted on that this is 1 and this is 2. Just now we said this 4, right? Y equals to x plus y. X plus y plus x plus y. Y equal to x. Now, for this B and this D, right? The gradient along this line and the gradient along this line, they are supposed to be 0. And I mean, 1 up, is it? 0, do you see? Okay, right. That's always 1. It's always 1, right? Wow, good point. Okay. Along the line, y got x plus 1. Okay. Right. So you're not confined to just these pointers. You could actually use many other way to check, like what you all said, you know. Typically, in AP exam, right, this kind of question always appear either on 28 or 29 or 30 of the MCQ question, you know. Typically, you know. Yeah, I noticed likely to come out in one question in the MCQ, non-calculator section. Okay, so with this, we can now move on to the next section on so-called first order DE. And you realize that there's a remark there, not in AP syllabus, which means you can take it easy, isn't it? Okay. This is what is called the first order, an example of first order linear differential equation. It is first order because the highest derivative is first derivative. It is linear because the dy, dx, the y, they are all power so-called 1, right? So if you have a d like this, it is termed a first order linear differential equation. In particular, there are occasions where such an equation is also called, in some instances, okay, is also called an exact equation. Where's the word exact equation? Is it described here? Exact differential equation. I would like to hear from one of you to explain to me why do you think it is called exact? And let's hear from, okay, next to, okay, I just cannot recall the name for a moment. Now the floor plan changed or not?
No.
Doesn't change it.
That one's in someone else.
Yeah, outdated already. I just get off my mind already. Okay, next to Caitlin. Brandon. I remember him sitting there, but when he sit there, I remember. But she only the Brandon. Yeah. Why is it called an exact equation? Why do you think the term exact equation?
Because it's exactly the product rule.
Because
Exactly what we get when you differentiate.
right, because if you were to differentiate this one, you get exactly the left hand side. Such an equation is called an exact equation. So let's look at one example. Okay, in 16a it shows you 16a and b. I want you to know beforehand that these two are exact equation. I like to challenge all of you to try write down what is inside these brackets. Okay, I see Kurdish looking into that screen. Okay, for the reason Kurdish has to fill in these two blanks. If you can't do it, okay, do it. Right. And next one. Right, you're right. Okay, press on, Kurdish. How do you solve this D then? So then you will just integrate the right hand side to give you. Brilliant! And likewise for this. Right. So if the equation are Z and you can identify it, it becomes very easy. What if it is not exactly a Z? Like for this, okay, let's jump a bit again. I'll come back to this later. Oh, this one a lot of reading, no. I can't take it, no. I can't take it. Okay. Okay, this equation is obviously not a Z. If you can make it a Z, you win. This equation is not a Z. This is say you can't potentially write this thing as like that. It won't work. It won't work. Okay, it's not a Z. Okay, let's have 1 minute silence to be to breathe over this because it's not exact equation. Yeah. Okay. Are you from drama club or something? Chinese chess. Okay, yeah, you told me this morning. Chinese chess. But how it connects to drama? Hey, by the way, I gotta give back your test paper though. Okay, Tyler. Let's guess his marks for test. The class. What did he get for his test? Do you all know? Of course he knows. Of course he knows. But do you all know? 17. 17 is wrong. Huh?
Higher or lower?
I'm not going to say.
18.
18 is not wrong.
I was close.
Because he didn't have his test paper. How about Mahil's test paper? Okay. Mahil is one example where grade doesn't matter. It's a talent, you know what I mean? He did well, he did well. But should be better. Okay, Mahil, come.
No, Mahal, congrats.
I always stress this to my daughter, though, because okay, my daughter's not exactly the academic type, but I told her, say, as long as you work hard, whatever you get, you just take it in a minute. Yep. Right. So I still believe that Mahil is a talent, though he didn't get full marks, you know. He didn't. Yeah, he didn't get full marks. Okay, example 17. How do we make it a Z? Dun, 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 dun. You need this magic, you know. Okay, you need magic power. By the power of earth and sun and the star, I declare this an exact equation. By the power of the earth, the star, and the sun, I have done a magic. By this magic, it has become exact. Hey, Mahil and company, what happened? What happened? Why are you getting 21, you mean? Mahil, you didn't get 21, Mahil, just sit down. Okay. Mahil, what happened to my equation? How is it it became exact? Wow, he used a term, you know. Okay, don't say. Okay, let's hear from. He said, if. Right, it's called the integrating factor. So Mahil knows such a term, no? Integrating factor. Do you learn it in physics or something? Did you learn it in physics?
Yes.
Okay. So that magic that we plug it in, it makes it exact, and the exact equation is none other than dun 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 dun. Nice, right? By introducing this term called the integrating factor, I have made it exact, and after that, I am able to solve this DE. Let me, and then I'm done. And I'm sure Arahi has a question to ask. Arahi, ask. You have a question to ask. Can you ask another question? Ask a better one. You have a question to ask already. You do. You will want to ask. Yeah, how to spell? Right now, how come I know this one will work? It's not by trial and error. It's not. And the truth is, to find the IF, it is always very mechanically done. It's always a E integration of whatever you see here. Yeah, it's always e to the power of whatever you see there. What is that? The coefficient of y. When you find the IF class, why do you think I put this as like that? Why they put it in dotted? Because this thing that you see now is fading away. We simply ignore that thinking. To find the IF, you just let me know. The thing just and it will always work. The common mistake among students in this topic is that you have to realize that before you can do the steps that I've just described, you must always rewrite your DE so that it is a single dy dx. Then whatever that appears here will be integrated to find your IF. So the thing is, you must make sure that the dy dx is a 1. Then that term in front of y is what you're going to use to find your IF. It's so mechanical. It's always like that. No? That's why I told you from the start of learning DE is you have to learn the type of DE and apply the solution method for the kind of DE. You know, it's just like if you're a doctor, one day you'll be one. You see this, you diagnose this illness, you apply these drugs. You know, same thing. Try the next one. If you now can try 18. Let's see who can do 18. Okay, number 18. To start off with, right? To start off with, as I told you, you must first and foremost rewrite as okay. A lot of students question or say, "Wow, are you assuming that x is non-zero?" We just for time being take it to be the way first. I don't know. Okay, take the way first. We solve it and then we verify that it's workable. Okay, we just be brave. Okay, just be brave. So then you have to find the IF. IF, okay? How to find IF is integrating okay, interestingly, let's see if you agree. The IF the IF the IF will be like that. You got it? Okay, great. Okay, anyone? The IF turn out with this. Kenneth, you are given 5 more seconds to agree. 5, 4, 3, 2, 1. Just be brave, lah. Just be brave. Just be brave. Just be brave. So if you believe me, then this look like this. And now the left hand side, once again, it has obtained freedom. No, sorry, exact became exact equation, right? What exact equation is this? It is the differentiation of right now. If you try to differentiate this one, you will truly get this. Do you agree? Then your y over x is equals to, and then finally your y is equals to, aha! Now that we survived the ordeal, we came up with this solution. You just now verify that this indeed is a solution. And I mean, just plug it in, differentiate once and plug in the left hand side, and show that indeed y equals to x squared plus cx is a solution. You know what I mean? If what troubled you earlier on, I want you to know that all the troubles are resolved when you reach the final ending point. It's not like you go for a cross-country run,
Yeah, just brush it off.
No, the logic is like this. The logic is like this. Once you get to the final, then you get the solution, right? You now bring the solution back to the start. It works. Just how the Thomas Edison got his light bulb. You just try blindly. Try with leather, try with beef, try with this. Yeah. Aha! The tungsten works, is it? Is it you use tungsten? It's fine. What do you use? Thomas Edison, what do you use? The light bulb works. You know what I mean? Same thing, So you just be brave. You just try first. And then in the end, you get an answer. If you multiply by x, there is no issue about x being 0 or not. It works. You know what I mean? You can verify that it works by just verifying. You know what I mean? You just differentiate once, plug in the left hand side, tidy things up, and then you see that you get x squared, and you're happy about it. And this solution, right, has got no issues about the division of x or whatever. That thorny issue just died off by itself, which is great. Are you all convinced or not? Or you think that I'm doing magic show? You're all convinced, right? Okay, this one it is done for you. Okay, this one I can read slowly. Okay. This was a very old question. No? Nice number. Where were you? Where were you? Almost. Not yet. Not yet on Earth, right? Not yet on Earth. You know the good thing about teaching math is the theory doesn't change. Yeah. Whereas if you teach, say for example, physics or chemistry, right, things might change. Last time they say proton, electrons, and neutron, right, are the smallest part of any particle, right? But later on they find that's just not true anymore, right? If you live in Newton's time, they were all very happy with Newtonian mechanics. All things work. But came Einstein that proved him wrong, You know what I mean? Right, so if you teach physics, right, you have to catch up with it every now and then, whereas math, luckily, it's classical theory, 1 plus 1 is always 2, it will never change, Physics changes, like last time you said light travels in straight line. All these books should be torn apart, Light doesn't always travel in straight line, because Einstein proved it, mathematically, and someone proven it in outer space that light does bend, If the mass is huge enough, light does bend. Someone first came up with the wave theory, like Hudgens, something like that, and everyone was very happy. Wow, wait. Then came who? Who was it that says particle? Albert Einstein, right? The photon effect, is it? One of the scientists I know. So things change again, Right? So therefore, guys, the moral story is join me. Join me. Just do math. Okay. In this question, it's suggesting to you that you want to do it by so-called substitution. To do by substitution, right? The very first step you need to do is to differentiate. Many people will differentiate and put like this, tell me what is wrong with this. It's wrong, right? It's wrong. U isn't a constant. If U would be a constant, then it's wrong. Right. Okay. So you just replace the left hand side with du dx minus 2 equals to minus 4u plus 1 over 2u plus 1. And then you tidy things up later bit. Simi. Check my arithmetic, I could be wrong, I could be wrong. Jingwen, you follow now? You get the same last line as mine? Okay, brilliant. Then after that, we want to and then now upon integrating this, and then lo and behold, what is your u? U is actually y plus 2x. U, what's u again? Is y plus 2x. And the thing is, sometimes it is very hard to make y the subject. You can leave your answers like this. It's okay, it's allowed. If it's not too hard to make y the subject, you want to do it, but if it's too hard and near to, okay, this is not impossible, this is still possible though. This question, it is still possible to make y the subject, it is still possible. I am sure Kurdish agrees, to make y subject, this one. A little bit harder than usual, but it's possible still to make y the subject. But you don't have to, the A-level TYS for this question, right, the answer key is exactly like this. Okay, I guess you have enough for the day, because you have another subject after mine, is it? Yes. What is it?
Yes.
Okay, so I think I should not stretch you all the way. We'll continue Thursday, right? Well, I see you tomorrow. Tomorrow.